Assalamualaikum and hi. For topic 6, we have polynomials. The subtopic 6.1 polynomials. At the end of the lesson, students should be able to perform addition, subtraction, multiplication, and division of polynomials. So for introduction, the word polynomial comes from two Greek words, poly and nomial, meaning many terms. So we have three examples of polynomials. We can see that we have many terms. And some examples of not polynomials where we have many terms but the exponents are not positive integers. All the exponents in the algebraic expression must be non-negative in order for the algebraic expression to be a polynomial. Many real life situations can be modeled by polynomial functions. For example, roller coaster designers use polynomials to describe the curves in their rides. So this is a polynomial that represents the function of the curve. So by definition, a polynomial, usually denoted by capital Px, of degree n with real coefficients, is an algebraic expression of the form of Px equals to an x power n plus an minus 1 x power n minus 1 plus so on up to plus a0. An is not equal to 0, where n is a positive integer, and the coefficients are real numbers. Degree of polynomial is determined by the highest power of x. Coefficient an is called the leading coefficient. For example, if you have 6x cubed minus 4x squared plus 8x, we can see here that the highest power of x is 3. So the degree of the polynomial is 3. So for x cubed, the coefficient is 6. For x squared, the coefficient is negative 4. And for x, the coefficient is 8. The leading coefficient is 6. Okay. Now move to page 2. Operations on polynomials are addition, subtraction, and multiplication. Polynomials can be added together, subtracted, or multiplied by a constant or by another polynomial. Example 2. Given Px equal to 2x squared plus 3x minus 4 and Qx equal to x squared minus 2x plus 5, find for part A Px plus Qx. So copy down the question first. Px plus Qx. Then we have to substitute both Px and Qx into the expression. Substitute Px, 2x squared plus 3x minus 4 plus Qx, x squared minus 2x plus 5. Then we have to simplify the expression. Combine the coefficient of x squared, so 2 plus 1 become 3x squared. Combine the coefficient of x, 3 minus 2 become plus x. Combine the constants, negative 4 plus 5 plus 1. So the final answer for part A is 3x squared plus x plus 1. Okay, next for part B, the question asks for Px minus 5qx. Again, similar to part A, we have to substitute both Px and Qx into the expression. Substitute Px, 2x squared plus 3x minus 4 minus 5. Substitute Qx, x squared minus 2x plus 5. Okay, then we copy down Px, 2x squared plus 3x minus 4. We have to expand the second term. Negative 5 multiply with each term in the bracket. So negative 5 times with x squared, it becomes negative 5x squared. Negative 5 times negative 2x become plus 10x. Negative 5 times 5 become negative 25. Then don't forget to simplify the expression. Combine the coefficient of x squared. 2 minus 5 become negative 3x squared. Combine coefficient of x. 3 plus 10 become plus 13x. Combine the constants. Negative 4 minus 25, negative 29. So for part B, the final answer is negative 3x squared plus 13x minus 29. Then for part D, we have to multiply px and qx. So copy down the question. So for part D, we have to multiply px and qx. Again, first we have to substitute px and qx into the expression. Substitute px, 2x squared plus 3x minus 4 times with qx, x squared minus 2x plus 5. So for this question, we have to expand the bracket. Multiply 2x squared with each terms in the second bracket. So start with 2x squared times x squared. It will be 2x power 4. Multiply 2x squared minus 2x. It becomes negative 4x cubed. Multiply 2x squared with 5. It becomes plus 10x squared. And we can add bracket for the terms. Okay, next, multiply 3x with each terms in the second bracket. You can use other color to distinguish. Okay, so plus 3x multiply with x squared. So we get plus 3x power 3. Multiply 3x with negative 2x. Become negative 6x squared. Multiply 3x with 5. We get plus 15x. Close bracket. Next, by using another color, maybe I can use green. Okay, next, we multiply negative 4 with each terms in the second bracket. So we have plus negative 4 times with x squared. We have negative 4x squared. Negative 4 times with negative 2x become plus 8x. Negative 4 times with 5 become negative 20. Then we have to simplify the expression. So how to simplify the expression? Look for the term with the highest power of x. So as you can see in the expression, the highest power of x is x power 4. And we only have one term for x power 4. So copy that down first, 2x power 4. Next, the highest power of x is x cubed. So we combine terms with x cubed. Combine the coefficient. Negative 4 plus 3. Negative x cubed. Then look for look for terms with x power 2 or x squared. So 10 minus 6 become plus 4x squared. Look for terms with x power 1. So we have 15 plus 8. Wait. So for x power 2, 10 minus 6 minus 4. Sorry, I made a mistake here. The answer should be 0x squared. So we can choose not to write it into the expression or into our answer. Proceed with coefficient of x. So 15 plus 8 become plus 23x. Then, and after that, find the constant. So we only have one constant here. minus 20. So the final answer for part D, Px times Qx equals to 2x power 4 minus x cubed plus 23x minus 20. So this is the final answer. Now move to page 3, operation on polynomials, which is division. A polynomial Px can be divided by a polynomial dx if the degree of Px is greater than or equal to the degree of dx. We can use long division method. This procedure is similar to the procedure in dividing two integers. So for example, we have 11 over 2. We can use long division. 11 divided by 2, so 5 times 2, we get 10. 11 minus 10, we get 1. So 5 is known as the quotient, 1 is known as the remainder, and 2 is known as the divisor. The above statement could also be expressed as 11 equals to 5 times 2 plus 1. Which also means the divisor times quotient plus remainder. So in the same way, division of polynomials can be expressed in the form of Px over dx, which equals to Qx plus Rx over dx, or Px equals to dx Qx plus Rx. When dividing polynomials, quotient and remainder can be found by using long division method. We only stop our long division when our Rx or the remainder is less than dx. For example, dx equals to ax squared plus bx plus c. We're going to stop our long division when our remainder is a linear ax plus b. Example 3 on page 4. The polynomial Px equals to 3x squared plus 2x minus 5 is divided by dx equals to x plus 2 by using long division, expressed in the form of Px equals to Qx dx plus Rx. So Px is the polynomial, so Qx is the quotient, dx is the divisor, and Rx is the remainder. Okay, to do the long division, put the polynomial first, 3x squared plus 2x minus 5, and put the divisor on the outside, x plus 2. So we have to think what times x to get 3x squared. So 3x squared divided by x, we get 3x, meaning if we put 3x on top, 3x times x, we get 3x squared. 3x times 2, we get plus 6x. After we multiply, we subtract. So 3x squared minus 3x squared, 0. 2x minus 6x, we get negative 4x. Don't forget to bring down negative 5. So to get negative 4x, we will multiply x by negative 4. So negative 4 divided by negative 4 times x, we get negative 4x. Negative 4 times 2, we get minus 8. After we multiply, we subtract. So negative 4x minus negative 4x, we get 0. Negative 5 minus minus 8, we get 3. So here, on top of the long division, we get the quotient. And the remainder is 3. Since the question asks us to specifically write our answer in this form, so we have to rewrite our answer. Hence, Px, which is 3x squared plus 2x minus 5, equal to Qx, quotient 3x minus 4, times the divisor, which is x plus 2, plus the remainder, plus 3. So that is how we do our long division.
Example 4, find the quotient and remainder for x cubed plus 4x squared plus 5x plus 2 divided by x plus 2. So in order to find the quotient and remainder, we need to do the long division. The upper part is the polynomial and the lower part is the divisor. So divisor should lie outside and the polynomial would lie inside. Then we have to cancel out x cubed, so we have to think what multiply with x will give us x cubed, or we can do the division. So x cubed divided by x will give us x squared. So we know that when x squared multiply with x will give us the answer of x to the power of 3, x cubed. And then x squared multiply with 2 will give us 2x squared. Then this one we get 0. 4x squared minus 2x squared, we will have 2x squared. Bring down 5x. And then think again, what multiply with x will give us 2x squared? The other way to do this is just we do the division. 2x squared, we divide by x, so we have 2x. So we put 2x here. So 2x multiplied with x will give us 2x squared, and 2x plus 2 will give us 4x. Then we get the answer of here would be 0. 4x minus 5x minus 4x will give us x, and then we bring down plus 2. Then for the last one, we have to think what multiplied with x will give us x. So we could just do x divided by x, which is 1. So we put plus 1 here. So 1 multiplied with x will give us x, and 1 multiplied with 2 will get 2. Then subtract, this one will give us 0 and also 0. So when we do the long division, the answer that we get here is actually the quotient qx, and then the remainder is 0. So we write down it properly. So qx quotient is x squared plus 2x plus 1, and our remainder, since we get no answer, so our remainder is equal to 0.
For example 5, find qx and rx such that x cubed plus 4x squared minus 1 equals to qx times x minus 1 plus rx. Okay, from this equation, we know that this one is a value of dx. Okay, now we do long division, which is dxu is a x minus 1, and px is a x cubed plus 4x squared minus 1. We arrange the px in a descending order, so we get here x cubed plus 4x squared plus 0x minus 1. To get x cubed, we times x by x squared. So x times x squared, we get x cubed. And then the next negative 1 times x squared, we get negative x squared. And then the next process is a subtraction. X cubed minus x cubed equals to 0. And then 4x squared minus negative x squared, we get here is 5x squared. And then we bring down the next term 0x. To obtain 5x squared, we times x by 5x. So x times 5x, we get here is 5x squared. Negative 1 times 5x, we get here is negative 5x. Okay, and then the process subtraction, we get here 0, 0 minus negative 5x. Here we get 5 5x. And then when bring down the next term, here is negative 1. Do we get 5x, which times x by 5. So the result here is 5x minus 1. So 5x minus 5x equal to 0. Negative 1 minus negative 1 equals to 0. So from the long division, we know that that's qx is x squared plus 5x plus 5, and rx is 0.